These are practice exercises from page 235 and 236 of the textbook, dealing again with electron configurations and specifically writing condensed electron configurations. So this first question asks us which family, another name for family is group, of elements is characterized by an ns2-np2 electron configuration. Remember that n is just telling us the energy levels, so this could be 2s2, 2p2, this could be 3s2, 3p2, this could be 6s2, 6p2. They're just telling us that in general, which family of elements has this electron configuration in the outermost occupied shell. So that's again another way to say valence electrons. Valence electrons are your outermost electrons. So if we look at this configuration, it's got a total of 4 valence electrons. 2 in the S and 2 in the P. So if we take a look at our periodic table, anything with 4 valence electrons is going to be over here in group 4A because it's got 2 valence electrons in the S and 2 valence electrons in the P. So no matter what we're talking about, it doesn't matter which energy level, anything with an outermost configuration of 2s and 2p is going to be here in that group 4a. So the answer to this question is that family, group, or column with that outermost electron configuration is going to be group 4a. Okay, taking a look at the next question, they're asking us to use the periodic table to write condensed electron configurations. What a condensed electron configuration allows you to do is instead of writing out a full electron configuration telling you the location of every single electron, you can use a shortcut, and that shortcut is using the noble gas before the element. So if we look at our periodic table, they're going to be having us write the first one for cobalt. They're telling us that's element 27. So if you look at your periodic table and then try to find it on this periodic table, you'll see that it's the 7th one in the D block, so that's cobalt. So if I'm trying to find the noble gas before that, so the noble gas with less electrons, that means I'm going to work back here. And that noble gas is argon. So to show you that I'm starting from argon, I put argon in brackets. And that means that I have all of the electrons leading up to argon. So that takes the place of 1s2, 2s2, 2p6, 3s2, 3p6, because that is the configuration for argon. So now I can just write what's past argon to get to cobalt. So past argon, I need 4s2 because I'm in the 4th energy level. So it's going to be argon 4s2. And then to keep going, I get into the D block. And remember that the D block is 1 energy level lower. So this is actually the 3D, and it's 1, 2, 3, 4, 5, 6, 7 in. So I'm going to write this as 3D7. Again, notice that the energy levels for the S and the D are off by 1, and that's because the D starts in the 3rd energy level, so this is a D3, underneath it would be D4. So pay attention when you're writing those electron configurations. Okay, the next element they're telling us is element number 52. So again, we want to find that on the periodic table, and that's going to be down here. Again, we find the noble gas before it, so that's here, and that noble gas is krypton. So again, we put krypton in brackets, and we just use the electron configuration for everything past krypton. So that's going to start us down here in the 5s. So it's krypton 5s2. We're going to go through the entire D block. So there are 10 electrons in the D block, and remember that that's D4. So I've got 4D10. And I'm going to end up back here. This is the 5p, so it goes 5s, 4D, 5p, and I'm only 4 into that, so this is going to be 5p4. A couple ways I can check to make sure I've done this correctly. I could add up every single electron that's in there, Or I could take a look at my valence electrons. Remember that valence electrons are in the highest energy level. So I've got 2 valence electrons here, another 4 valence electrons here is a total of 6 valence electrons. And that makes sense since my element is in group 6. So when you do this condensed electron configuration, make sure you're finding the noble gas before the element you want. Put that noble gas in brackets and just write the electron configuration for everything past the noble gas.